welcome back to Blockchain Build Day. Thank you all once again for joining us. It is now time for our last presentation of the day on the fundamentals of hosting nodes on EOS.io chains. So for this presentation, we're welcoming Rob Consdorf, the CEO of EOS Detroit, which is a block producer on the EOS.io on the EOS mainnet. So I'm going to be removing my screen shortly, and Rob, you can take it away. Thank you.
Thanks a lot, Kristen. Let me just get this going here. Here we go. So hi, everyone. Thanks for tuning in. It's been a great blockchain build day. Been listening to all the great talks. Really appreciate all the knowledge sharing. So my name is Rob Consdorf, aka Rob Rigo. I've been working in the crypto space for about 6 years now. Got involved with BitShares early on BitShares talk, and sort of been following the evolution of what is now the EOS.io stack over the last 6 years. So today I'm going to talk about what goes into hosting EOS.io nodes and sort of a broad overview of what that means. What is an EOS.io node? Why might you want one? How do you go about learning about this stuff? Hopefully this will be resourceful, and we can always follow up after if there's additional questions. So yeah, I mean, really, EOS.io is a blockchain tech protocol. Saul went into it quite a bit earlier on the dev side, which is great. And, it's designed to be quite performant, easy to develop on, very customizable, and just in general, a really strong piece of technology for launching blockchains. So yeah, I mean, it's great. It's sometimes hard to take a step back and be like, what don't people know about the thing that I spend all of my time studying? But I'm going to do my best to sort of assume no prior knowledge here. And if there's any questions, we can clear that up at the end. So yeah, in general, there's all kinds of tech stacks. There's, the original Bitcoin protocol. There's Ethereum, which came out in 2015. There's various flavors of delegated proof of stake, whether that's BitShares, Steem, EOS.io, proof of authority. There's all kinds of different blockchains based around kind of their core consensus algorithm is what makes them different. They can use different implementations of code, but that's sort of like the fundamental piece there. And EOS.io uses something called delegated proof of stake, which is essentially a system where block producers are elected by people who hold the cryptocurrency assets. So everyone who has the token has some representation in the system. They're able to choose who they'd like to hire, essentially, to run the network. And so those hired entities are known as block producers. Here are, the top block producers on EOS, starting from rank 1. They're ranked by vote. So, Hubi Pool has 317 million votes, and so on and so forth. And so what matters here, though, is once we get to 21, there's a cutoff here. So the top 21 block producers are known as the active block producers, and they're actually the ones that are processing transactions and including them into blocks and validating the smart contract logic. And so they're the ones that really have to have high availability. I mean, all block producers should have high availability. I'll get into that a bit in a second. But, if they don't, the network performance will immediately suffer. People will notice it. You may send a transaction and it might not go through, it might not get included for a while. So, it would take some time for it to get included rather. So yeah, we want to make sure the top 21 on any EOS.io network is strong and, providing the right infrastructure. So after the top 21, by the way, also get something known as block rewards, which is every time they sign a block, they get paid in the core token of the EOS.io network. So for EOS, that would be the EOS token. For Wax, that'd be the Wax token. For Telos, that'd be the Telos token, and so on. So after 21, we've got this cutoff down to 22, where there's what is known as a standby pay. So you can see top 21 here, and then standbys in this label here. And the standbys are incentivized to keep a production-ready infrastructure so that in the event that the top 21 fail or someone has to unregister, there's nodes waiting to replace them. You know, what if a government coerced one of the top 21 to shut down their company? Well, we've got tons of standbys here waiting to take their place. So that's not too big of a deal. The real attack is if you can subvert 2/3 plus 1 of the active producers. In that case, that'd be 15 out of 21. But that is actually an attack I don't believe has ever been carried out on a DPoS network. So if we scroll down here, EOS Detroit's actually not on the first page. We're on the second page on EOS, but that's cool. We're crawling up. So we're right here on 56. And thankfully getting paid again, thanks EOS stakeholders. That's very helpful. And essentially we take that pay and reinvest it into our team and our infrastructure and making sure we're building and adding value to the network. So that's our business as a block producer. And what we're looking at here is blocks.io. This is a block explorer by the EOS Cafe block team and HK EOS, two other block producers. So we see block producers kind of specialize in different things. And if we look, you can log into different networks actually through blocks. So it supports multiple interfaces. So if we were to click that, you'd be able to see like Wax and stuff like that. But I'm not gonna go too deep there. Just wanted to give an overview of how you look. This gives visibility into the network and the chain, which is very helpful. On top of that, it also allows you to sign transactions. So if I were to log in with my Anchor wallet, add account, I think this will work. So sometimes Anchor's new, but this is a really good wallet that the Gray Mass teams actually built. Well, I mean that, let me just, not Wax either. If I log in here, we'll see Anchor will pop up because I have Anchor Wallet open on my desktop and I have an account in there for EOS. Anchor Wallet is a signature provider that implements something called the EOS.io signing request standard that Gray Mass helped champion. And it allows us to sign transactions very quick. So now this is my Anchor Wallet and I can sign into blocks, get this pop up, click the button, boom, I'm signed in. Now I can do stuff with my account. So if I wanted to, I could transfer easily. You know, I could send some tokens. You can do all kinds of stuff. Manage your resources. This is more advanced user stuff, but as you know, devs and people looking to operate EOS.io networks, which I assume is the target or the sort of audience here, this stuff is useful. And if you are like, hey, I have a smart contract, I don't know how to send transactions to it easy because Kleos is too hard to use, which is the command line tool. You can actually look at any smart contract right through blocks. You can click contract. You can look at all the data and look at all the tables. These are all the block producers, I think. Or no, these are ABI hashes. But if we look at the producer table, you can see registered producers and what key the network expects. And you can also submit transactions yourself. So, you know, say I were a block producer and I needed to claim rewards because I was getting paid by a network and I didn't have that automated yet, and click this little, wherever it is, there it is, claim rewards. type in my BP name, EOS Detroit, submit. This one actually worked because I'm not signed in as EOS Detroit, but just to give you an example of the flow, Anchor tells you what you're signing, so you have a guarantee you're not kind of getting tricked into signing something bad, which is something we need to think about as people developing and building on these blockchains. And then you can sign it if you're agreed. This won't work, or maybe it will. I guess it lets me try to claim rewards even though I'm not that block producer. Or no, missing authority. So that just means I don't have the key for EOS Detroit. But if I did have that key, look at that. If I did have that key, it would have to be one that matches here. So another cool thing in blocks, you can see what an account's voting for, if they're proxied or not. You can also look at the permissions of an account. And in EOS.io, we can set custom permissions. So you can actually make it so certain keys can only call certain smart contract actions, which is really useful for, principle of least privilege security model. And, you can set up multi-sig pretty well with this too. I don't have a multi-sig on our BP yet. I actually just got another tech guy on the team. So we'll set that up eventually, but yeah, you can set up all kinds of cool arbitrary permissions. Like if we look at the travel refund smart contract, which is a distribution mechanism for subsidizing the cost to travel to the EOS community conference, this is what a multi-sig looks like. So if we look at the keys here, there is a weight of 3 for the active permission, which active is your hot permission, kind of like your hot key, while owner should be your cold key. Ideally generated offline. You shouldn't use that unless you need to change your active because it's been compromised. So the owner gives you a way to take back control of your account if this were to get leaked somehow, whether that's malware or you've been phished or some other horrible thing happened, coerced physically. So what this means is we need 3 signatures to satisfy the active permission, and each of these signatures provide 1. So we need 3 of these block producers to authorize it in order to make something happen with the active authority, which is sort of like your default master key that can do anything. And if we look here, there's a special one called eosio.code that's actually required for a smart contract to authorize its own transfers and stuff. So by setting this, we allow this account to use the smart contract it has installed to satisfy the active authority. And what that means, because this is +3, so the smart contract can do it itself, doesn't need anyone to help it. And so that's how the smart contract generated transfers automatically to disperse this fund to subsidize travel. So that's an example of some permissions there. It's a pretty cool system. And of course, you can see some history. So if we scroll down here, we see these were the actual distributions of this smart contract. And that was just sort of crowdsourced and funded by block producers for the EOS Community Conference in Rio last October, which was an amazing event. I was really thrilled to be able to go and be with my EOS family. I did want to start with that just to sort of get us going, and I can get rid of this incognito. I'm actually going to jump in more about sort of my thesis around EOS.io and what block producers do. So I'll pull this over here and just run through this pitch deck really quick. Oh, not that. Yeah, so EOS Detroit, we're a guardian of the EOS.io galaxy. We're a security company. Block producers are security companies. We have to secure this blockchain network and keep our systems secure so that the world can derive trust from the network. But the cool thing about what we're doing is there's no single point of failure. So it's all of our aggregated security and efforts sort of give us this resilience and anti-fragility, where even if EOS Detroit were to be coerced or stopped or whatever, there's always all these other nodes that'll replace us. And that's actually part of the reason I developed with my team something I'm going to demo at the end, but we'll get to that. So if we go on, we're a block producer. We provide infrastructure and support for blockchain networks. We also provide governance expertise. And blockchain governance is a really interesting, sort of hard to nail down. It's a bit of an elusive topic because there aren't even shared languages between all the different projects in crypto yet to sort of talk about it. And there's also the incentives that each project has to sort of promote itself and maybe not promote its competitors, or even spread misinformation about them. But I'm not going to go into that too much. So yeah, we provide infrastructure currently for EOS, Telos, Wax, Proton chain, which was Link's chain, and FIO. And also the OR network, but I didn't have enough room on the slide. So sorry, OR. Oops, I gotta figure out how to use, I don't do this that often. There we go. Okay, so yeah, I mean, blockchain tech's really promising. Like, I think we all are here because we believe that. But it's really difficult to use, or has been traditionally for the last decade, or a little more than a decade now, since Bitcoin came out. Whether it's slow, expensive, requires in-depth knowledge of how to secure cryptographic keys, understanding of technical jargon, you name it. There's so much complexity here. And Ian Grigg actually had this great slide he posted on Steam once that was sort of like, what we're doing is the intersection of like 15 different disciplines, whether it's law, finance, political science in a sense, cryptography, computer science, and so on and so forth. So essentially we're intersecting all of these different disciplines and everyone's sort of applying their own meaning to this technology. But at the end of the day, it's tech. It can be used for good, it can be used for evil. But yeah, it's interesting stuff. And I think a lot of great things will be done and already are being done using this stuff. So yeah, this is sort of the problem, current options are a little slow and expensive and unforgiving as far as developer experience goes. And also we have issues with how to make decisions collectively, where, in traditional systems, there's always been shadow governance, kind of, whether that's the Bitcoin mining pools getting together in a room and talking, or, back in the early days, I'm sure it's changed a lot, or, just people deciding they're going to go their own way with the project and doing what's known as a contentious hard fork. Examples of this being Bitcoin and Bitcoin Cash, and then Bitcoin Cash and Bitcoin Satoshi's Vision, and Ethereum and Ethereum Classic. And more recently, this is probably the most interesting contentious hard fork for me, Steem and Hive, which was the first contentious hard fork of the DPoS network. But yeah, that's like basically the community fracturing into multiple camps because they don't agree with the direction the other camp wants to go in. They have no means to resolve this without going to war. or maybe war is the wrong term because it's not violent, but rather without pressing the big red button, the nuclear option in a sense. So we're focused on operating these blockchain networks, and one's with a purpose, one with, a good team, a vision for what they want their network to do, and some sort of differentiation. I don't think forking and creating a bunch of coins or whatever is a useful pursuit, unless there's actually some weight behind it and some thought and some vision behind it. So we look for that. And EOSIO has a lot of really great features. I personally think it's the best blockchain tech on the market, but I may be a little biased. It allows you to use C++ code to write your smart contracts. They're highly optimized. It can process thousands of transactions per second, and that's always increasing because we've got block one building the protocol and continuing to improve it. And they just sort of release it and give it away to everyone. So it's an amazing resource where this corporation is able to, handle the protocol development, so each team can focus more on the application layer or on the purpose of their specific network. And so as a BP, we provide network validation, API access, so we provide public endpoints that dApps can use to integrate their app. We also provide peering services, which is a P2P endpoint, which basically allows the EOSIO nodes to connect to each other and transmit blocks to each other. So blocks can propagate and broadcast through the network. And we also work on some governance pursuits. Adam's been a part of the Telos Foundation, my co-founder and COO, and I'm working with the WACS Office of Inspector General as well, which is a pretty interesting project to figure out how to evaluate guilds, which are another name for block producers. So, we're entering a new paradigm in internet services. Basically, EOSIO is the backbone. We need to have these networks. They need to run well, need to get all the bugs out so that good applications can build on top of them and rely on them. And businesses can be built on them without having to worry about having an enormous risk to their business model or their app, or if the chain's going to just fail one day. And that's how we get the end users. So we have to have the networks to build the user experiences to attract the people. And in cryptography, they call this a trust anchor, what all the block producers do. And that's kind of what I was mentioning at the beginning. We're all basically, it's our reputation, it's our competence, it's our being allocated through votes, so reflected in the votes, typically, that allows us to run these security companies that coordinate with each other, but also compete with each other in order to provide a highly available and secure network, or multiple of them. I think almost all of these block producers run more than one EOSIO network. So we need this, like I said earlier, so we can build dApps. And I'm not going to get too deep into this because I covered some of it, but EOSIO-backed blockchains account for over 85% of all public blockchain activity today. That's quite the statement. And B1 has a few billions, so they can afford to keep maintaining it. And we've got some cool products coming down the line. Tops just launched Garbage Pail Kids last week on Wax. I think that's been the most successful DAPP launch I've seen to date. Voice is in beta. This is an amazing app that I'm excited for, and I think really has a chance to change the way people think about social media. And for the artists and creatives, we've got newlife.ai, which are coming to Telos, and they're doing some really amazing stuff and really focused on creating almost, I like to think of it as a union for creatives to collectively bargain and get more value and sort of have their own innate digital currency they like to use. And Blankos, this is a big AAA, gaming studio, or a game being developed by one called Mythical Games. There's many apps. I only had enough room for 5, and then this one's over here is Metal. Metal X just launched. That's actually they're building out a exchange that's compliant in the US using the Proton chain. So that should be a really cool exchange project to watch. And yeah, so I kind of touched on history before. It's been 11 years now, and come a long way. And I'm sure there's many branches of the blockchain history I'm missing here, but this is the one that pertains to what I've done. Yeah, so Ethereum really sparked something, though. As much as I'm not really into using that tech, because they got people super interested. They got the mystique out there. They did really good at marketing and branding, and got people interested. And they have a massive developer community, probably the largest in all of the crypto space. So pretty awesome. And I should probably change this, cross that out and say Hive, because I'm a Hive sympathizer. But on that point, something crazy happened today with that. And I don't know if anyone saw, but the Steam VPs were attempting to basically delete some stake from Steam users who supported Hive. And an insider sabotaged their plan, or partially sabotaged their plan, by transferring a bunch of it to the Bittrex account. So now Tron has to, or not Tron, sorry. Now Steam has to choose to either freeze Bittrex, which would be freezing an exchange account, or they're basically hands are tied, and Bittrex gets to choose the next move, I guess. So this is better than a movie plot, really. And I think, I don't think I could have written a story like this if I was just dreaming it up. It's very fascinating. So it's time. We have good technology. Things are maturing. The mass adoption hurdles are being surmounted, whether that's throughput, figuring out resource models that allow business models to scale instead of passing the buck to the users and saying, oh, everyone's going to be okay with paying 10 cents anytime they want to do anything. Or if everyone's using the network, $10. And this has a problem because we can't do good UX without having quick finality of the state of the blockchain, which is a high assurance that these transactions can't be reversed. Very high assurance, and asking people to manage keys. That's not going to happen. We can help them manage keys. Could probably, especially if the big Google and Apple open up a little, could probably put the key right in here and make it real easy to back that up to the cloud. So there will be ways that users can use the keys natively, but so they can still have the sort of security experience of not relying on a custodian, but it's difficult. And we're on our way. And I think EOS.io will address all of this. I think that's been a major focus of Block One because they understand the hurdles to mass adoption. So, there's a good market opportunity, lots of money sloshing around in digital assets. We've seen, frothy bubble pop recently in the beginning of 2018. And there's a huge market in enterprise blockchain. And as more and more success is seen building things with this, we'll inevitably see a big pile on, because a lot of people, and especially more conservative businesses, don't want to be the guinea pig. But if they can see it working for their competitors, maybe, then they might jump in and start using this stuff and start figuring out how to leverage it to build better business models or to improve the efficiency of their operation, or create, it's a natural audit log if you do it right. So yeah, and funding continues. There's still tons of money pouring in, regardless of the market prices over the past 2 years. So yeah, we compete against other block producers, but it's friendly competition. We all want to build the best network together. I don't think there's been too much cutthroat competition per se, and most people are willing to help each other out. And we've been a really resilient company. I think our company should have died a few times, but we kept finding new opportunities, and really had made a good decision in the beginning to do a dynamic equity split, which allows us to continually dilute our founding team, and easily create an incentive in a cash-strapped environment for someone to join our team and work with us. So yeah, we've built up a reputation. I'm going to skip over the pitch parts. This is more of an educational video. So yeah, I mean, I'm going on, but we have to run a highly available network. In order to do this, you need to know something about systems engineering or site reliability engineering, DevOps, how to manage highly available web scale eventually service. And there's also some specific agreements and requirements depending on the network. They each sort of have their own flavor. Anyone on the public networks can register a block producer. So on Telos, on EOS, but some of the more consortium networks, Wax is actually open entry as well. You just have to show up and do Office of Inspector General interview and participate in the evaluation process. But there is, some networks that have just chosen block producers and run with them, like Proton's doing that, so it's more of a consortium network. And that's kind of the beauty of EOS.io as well. You can have an EOS.io database that runs on one node internally to a company. You can have some private sort of, only some entities are allowed to be block producers, or there's some vetting process that requires a decision maker to say yay or nay. So more consortium network. You can have a public network like EOS that anyone can register and jump in and try to make a living. So let's see. Yeah, and BPs, because this isn't very well defined. I mean, there is a core job. Job zero is that security job and being able to scale and provide the infrastructure. But beyond that, what do we do with the rest of our time? A lot of people are teaching. A lot of people are writing code, building tools, releasing open source, building products, consulting, you name it. They're the ecosystem's best evangelists. Yeah, I'm not going to talk about our contributions or what we're going to do. but BPs literally print money, and it's kind of cool. So what we have with a DPoS system with inflation, which I think is all of them, other than BitShares. BitShares actually just had a pool. It didn't use inflation at that point that I remember, but it could have changed by now. I haven't followed it for years. But essentially, these networks are able to fund their own growth, and they can hire talent through these inflationary mechanisms. So the network, if the voters are aligned and paying attention, which is a lot to ask actually, and that's why we have voter proxies, which someone can give their votes to someone else that they trust to vote on their behalf. They can pick talent to hire, or nodes to hire, or people behind those nodes that will add more value than they cost. So it's a good deal. It's why any early stage startup hires. And it's up to each of these nodes to market their value. So we can't just sit around and wait for people to notice. You kind of have to get out there and bang your chest and yell at the top of the roof and make sure everyone sees what you're doing too, if it's valuable. But back to the inflation, this is really cool. And so on EOS, 1% of the inflation goes to block producers right now. And there's another pool for worker proposal, but it isn't inflation funded. On Telos has actually done some really interesting experiments around inflation. But essentially what Telos has is a worker proposal system that allows people to be hired to implement projects. And that means even if you don't know how to run the nodes, the network can hire you too. Wax also has this with Wax Labs. So essentially, Wax Labs is a little bit, it's not fully on chain yet, but I think it will be in the future. But on Telos, worker proposal is fully on chain. And the stakeholders can choose where the funding goes. So that's pretty amazing. And it allows these networks to be self-funding. A bunch of people can literally get together voluntarily and decide they're going to create this project and raise up their own network and put in hundreds of hours of work and all of this stuff. But at the end of it, they can have their own economy, period. It's an economy. Don't matter how small it is, it's still an economy. So we literally have the tools to create our own economies. I guess if you thought about it that way, the BPs would almost be like a different kind of Fed, but fully transparent. And that's a huge difference. And also, our money isn't stable. It's actually more of a resource. It's a utility because you need these tokens to you need to produce these tokens and stake them or lock them up in order to get a grant on the network's resources. And some of the networks are changing those dynamics too, and this is the fun of it. So FIO has a fee-based system. I think it's the only fee-based EOSIO. So we can take that core protocol Block One's launching, but because the smart contract language language and VM and system and architecture is so elegant in a way, the system's internals are implemented in the smart contract layer themselves, which makes it super easy for all these different networks to tweak how they work, but still share the same base layer code. And that's pretty huge. And they call those the system contracts. They're the contracts that the block producers have authority over. 15 out of 21. Yeah, I'm gonna get out of this now. We've been talking about EOS Detroit for a while. Let's move on. So yeah, because I wanted to show you this one last thing on that point. Back to these keys. EOSIO.prods is how EOSIO account is controlled, and this is the system, and these are the system contracts. And well, there's a few different system contracts and different accounts. So EOSIO.savings, EOSIO.msig, there's a few different ones. But EOSIO.token is the contract for the EOS token. But the point being with these keys, this EOSIO.prods actually represents, if we look at the keys, 15 out of 21 of the top block producers. There's 21 BPs here. And this is what's known as a virtual account that is changed periodically whenever the producer schedule changes. The producer schedule changes dynamically based on votes, or if a producer decides to unregister themselves, which will happen often if you're having an outage. The right thing to do is producer unregisters, fixes their system, and then re-registers. You don't lose your votes from unregistering. You just get taken out of the rotation temporarily. So that is a little crash course. And let's see, how much time do I got? About 20 minutes. Yeah, next I'm just gonna show you a sneak peek on a tool that will be launching by the end of the month. We're still ironing out a few bugs, need to write up some docs. But essentially what it is a set of what are known as playbooks for managing all sorts of different aspects of setting up, running, and configuring a node, allowing the operator or dev to easily override any configs and use our playbooks while maintaining their private configuration data separate, so they can keep their private, any keys they need, any of that stays out of the repo. It's separated from this core set of automation tools we built using a technology known as Ansible. So a lot of the people are using something called Docker with Kubernetes nowadays, but that's not how I roll. What we have here is something called Vagrant. And I'm actually going to, if I just say Vagrant, this will work. What Vagrant does is it allows a developer to easily bootstrap a virtual machine in a specific state on their computer by running one command, Vagrant up. So I'm in a terminal. This is a Mac OS environment, but this would work on Ubuntu as well. And this takes a minute for it to start up, but it's starting a virtual machine that's running Ubuntu 18 long-term support. And it is essentially going to set up this Ubuntu virtual machine. So there's another computer running on my computer now, and sync down this playbook code. So this is really helpful because we can standardize the environment we're deploying into. You could use this with any operating system you wanted that EOSIO supported. We just chose Ubuntu because it's super well supported and we're most familiar with it. But essentially, because we run Ubuntu all over our infrastructure, they're actually mostly in the cloud still and working on a bare metal transition right now, but we're running Ubuntu servers in the cloud, and we do have a couple bare metal in a few different places, mostly for our producers. But long story short, by testing against Ubuntu locally on my dev machine, while I'm working on these playbooks, I can make sure that I'm going to get similar results when I go to use this in a test or production setting. So it eliminates the whole class of errors around environment incompatibility. The Vagrant machine is started. if I go up here and say Vagrant SSH, it'll actually connect me to it. So now I'll be on this Ubuntu machine. Oh, let me just do something really quick. Grab a couple fixes. JP's working on this right now. He's making the final push to open source this. We actually had to do quite a bit to convert this tool from something we were using internally into something we can share. So that's what we've been focusing on. But in a few simple commands, so I'll just give you a quick example of the direction we're heading in. If I say Python, let me just double check one thing. Sorry. Yeah, I need to do this other thing first. So Python 3 CLI wizard and reset. Warning, this will destroy everything. Yes, because I'm giving a demo. So now if I look, it should be less files. Yeah, so I don't know. Let me make this a little bigger for the, oops, what'd I do? I see. I'm gonna just make this text bigger so it's easier to see. Okay, so we've got a lot of text in a terminal here. I know this will make a lot of people's eyes go crossed, but for some of you, it'll be very natural. And what this is a symlink, it's called. It's a symbolic link. It's basically a thing in Linux that lets you say this sort of reference to a file points to this other place on the file system. That's the best way I can explain it. This is basically a way to refer to some other file with a file. And this is how we keep the private data that one might be provisioning. Like as a block producer, you may have a signing key. Best practice is never to leak any keys. So you're gonna need to put that signing key in a private place. And Ansible actually also allows us to encrypt that. So we'll take all of the keys needed for the deployment, put them in a private place, encrypt it, and then the dev or the operator can commit that to their private repository while they're still leveraging the open source code that we'll be maintaining. So essentially, anytime we're making updates to make our system better, everyone in the community can get those too, if they want to use this same scheme. So let's go through this one time. Got Python 3 CLI wizard set up. So right now we're just going to sort of explicitly support chains so we can make sure everything's working well. So here you'd be able to say, I want this node to represent, an EOS node. Node type, for example, not going to make a producer. That's actually dangerous to make a producer on your local machine if it's using your production data and you're an active producer. You never, as a block producer, want to have the same signing key configured and synced to 2 nodes as a producer. It's bad. Just don't do it. It'll fork the network, you get fired. And that's a known failure state. So don't do it. So I'm not going to pick producer. I'm going to pick V1 history actually this time. So now we can say where we want to deploy to. And if I were to pick test or prod in here, it would actually ask some more information. But because we're doing this locally, I'm going to take the happy path through it. And I also don't want the demo to fail. And I haven't fully tested all this. It's close though. But if I were to say test, it'd ask you for what's your IP. It would ask you what's your host name. It'd ask you maybe what's your public API endpoint, since I'm doing a V1 history. What's the domain? For us, that would be api.eosdetroit.io, for example. So what do the devs configure in their app to actually talk to your node? And this will automatically generate what's known as an inventory file. So I selected dev, and we still got to add the auto encryption and make things sort of safe defaults, which we'll be working on over the next few days. And I'm going to create the symlinks. That'll probably be a default too. So you see those were created. And now we have those files again. Group vars mapping to the stop private. Inventories mapping to the stop private. So we just created new files. And if I look in my Git version history here, I don't see them. Well, that's simply because I Git ignored them. So .private is Git ignored here at the bottom. And what .private will be, this will be your own separate Git repo. So we're actually going to put a Git repo in a Git repo, which is a little weird. That'll allow us to run Ansible playbooks with your own private data separated out. And so now that we've set up, let's give it a shot. It just takes one command and you'll have a fully bootstrapped node set up. So Ansible playbooks, the entry point, or actually you say Ansible playbook, then the playbook, that's the entry point. So we're gonna do one called initialize EOSIO Genesis node. We've also got initialize EOSIO snapshot node, which will use a configured snapshot in order to create a node that doesn't have to sync from the first block. On any network that's been around for a long time, if you don't need the full history, that's probably what you want to do, because otherwise it will take a very long time. Let me use Genesis for the demo. And -I is inventory file, so inventory/EOS, that was auto-generated by our guided setup. And the inventory is just what is the node's name, what is its IP, what is, information so that you can connect to the node. If you're using SSH authentication, you'd need to put perhaps a config to a key there, unless it's already on your keychain. If you connect to remote servers, you already know what that means, so I'm not going to explain it. If you don't worry about it. And anyways, let's run the sucker. So target equals dev, and I hit enter, and now it's going to run and basically run a bunch of series of commands to set up this machine up here. Oh, we haven't created the EOSIO user just yet. It'll do it in a second though. So let me make that a little bigger and this a little smaller. Okay. So it takes a little time to first set up. It's gonna update the system. It's gonna initialize and install, set up some permissions, create a deploy user. It's going to do a few different things. And what this is Ansible. So Ansible is really cool. It's maintained by Red Hat. It allows us to easily compose automation playbooks to make setting things up consistent and easy, which the more your infrastructure grows, the better having something like this is, because there's no way you're going to keep everything in your head about what you did on every single server. And what this allows us to do is version control all the changes we make to the configurations of our nodes, so we know if it breaks, how to revert it, and a number of other useful things. And it actually is pretty slow right now. I actually figured out how to optimize this, but I haven't gotten around to it yet. So this will be a lot faster when we get there. But yeah, and so it is a little slow because it creates a separate connection for every command it runs. But after this command, it'll go pretty fast, and we'll make that a little faster. So yeah, essentially what's happening here is we're running something called initialize system. This is an Ansible role that does things to initialize the Ubuntu machine. It doesn't worry about anything related to EOSIO yet. So we've kind of got all of that logic separated. So it's easy for contributors to see what part of the code they may want to modify if they start pushing pull requests to our repo. Here we go. So now it's going. Now I can actually become this EOSIO user and look at the system logs, and we'll see it start a node here in a second. Let's see here. Looks like I'm right on time with this demo too. Cool. So things are happening. This is all the stuff you have to do to deploy a node. Can be troublesome. And here we go. All of this output is the node looking for peers. It'll start syncing soon. It always takes a long time to sync the initial blocks of a network like EOS because we had a Genesis snapshot installed into the Genesis block, which is how everyone who had the EOS ERC20 token were able to claim and have their EOS on the native network. And so what that means is there's a lot of data in these initial blocks. There's this whole BIOS sequence of booting an EOSIO network where you have to install the token, print the token, do all kinds of stuff, and inject a bunch of data. And so that's why the first few thousand blocks take forever or take much longer. It goes faster after. And essentially, we can see it's requesting blocks now from the peers that it connected to, and it is going to sync. And as of today, EOS is actually on block 121,737,954, and we're syncing block 4,000. So this is going to take weeks and weeks, months, maybe. Depends on your internet and a lot of things. But long story short, syncing one of these nodes from scratch is really hard. And there's actually some great providers. Like I know EOS Sweden has some good snapshots and EOS Amsterdam too. I don't have the links on me, but you can actually get snapshots of the block log. So you can just pull all the blocks down. You don't have to download them through this peer thing and that sort of thing. So there's ways to expedite these, and we actually have a feature built into the Ansible playbook that allows you to pull a block log from, I think, from Amsterdam. But yeah, so we're not afraid to integrate everyone else's stuff into our stuff too, so we can make it easier for everyone to use everything. That's kind of the idea here. And getting back to the original point that I made when I started the pitch, this is important to make these nodes super easy to run because it'll make these networks way more resilient. So if there ever is a coordinated attack against an EOSIO network, we have documented open source knowledge of how to run these things with a high degree of efficacy. And others can do it easier. So we can pave the way for others to participate and learn quicker. And so my time is almost up here, but as we can see, it's syncing now. I'm actually gonna just destroy that VM because I don't want it running. And that's the power of Vagrant. You can just destroy and recreate your environment. You don't have to worry about how did I configure the config file. Everything in the Node.EOS config, Nginx config, all the configs of all the services, Hyperion config, all of that is overridable through here. I didn't go into that more advanced demo, but the idea is you can basically quickly change any aspect of the system easily. So that is my talk. Thank you for coming. Thanks for listening. And I'll drop my email here.
Thank you so much, Rob. That was really, really, really cool. I hope this, significantly lowers the barrier to entry for hosting nodes on all of the chains that are, working with EOSIO software. Very cool work.
Thank you. Appreciate it.
Absolutely. So this concludes Blockchain Build Day. Once again, thank you all for attending. We will be posting recordings of each of our sessions on YouTube over the next couple days, so keep an eye out for that. Anyone who attended will be emailing you out links to those once they're up. So once again, just thank you so much for your time today. We hope that you can take some of the knowledge that our speaker shared with you and use it to scale your projects during these strange times. So thank you for attending and keep building. Bye-bye.